area, rhombi and kites. Formula not on the reference sheet. Everything is based on the diagonals of a rhombus or a kite. The length of the diagonal. So remember, a diagonal is the length from one angle to the opposite angle. In a quadrilateral, there's always two diagonals. So diagonal 1 is this horizontal one from this vertex to this one. Diagonal 2, vertical from here to here. Does it matter if I call the horizontal one diagonal 2? It does not. Which that designation 1 or 2 is not important. So this is a rhombus. This is a kite. The formula for the area of a rhombus or a kite is 1/2 times the length of diagonal 1 times the length of diagonal 2. So we have worked with rhombi and kites early in the year. We have worked with their diagonals. We should, we did learn, so we're reviewing now a refresher, that the diagonals bisect each other. So diagonal 1 splits diagonal 2 into two congruent parts. Diagonal 2 splits diagonal 1, or vice versa. Diagonal 2 here splits diagonal 1 into two congruent parts. Diagonal 1 splits diagonal 2 into two congruent parts. So this length and this length are the same. Oh, but just on the kite, it's just this one. Make sure we know that. On the kite, this one is bisected, but this one is not. The rhombus both bisect one another. Okay? So let's be more specific. So rhombus diagonals bisect each other. I don't think they give you any where you have to remember that. But the shorter diagonal in the kite is also bisected by the longer diagonal. I think we're just working with the rhombus bisectors. All right, questions so far? If you didn't write this down, make sure you did, and including the word rhombus in there. So we're going to do an example. In the rhombus, PQRS below, PR, the length of segment PR equals 28. So PR is 28, and the length of segment QT equals 10. So QT equals 10. So we're going to go ahead and label that. So diagonal 1, we could call PR. PR, we know that diagonal 1 is PR. We could call it diagonal 2, but we're going to do that one first because that one's a given. So we know that that one's 28. Diagonal 2 is SQ, or QS. And we don't know the length of diagonal Q, or diagonal QS. But we do know this length. And we did get reminded that in a rhombus, the diagonals bisect one another. So if this one's 10, what's this one? 10. So now we know that the length of this diagonal is 2 times 10, which is 20. So far, so good? So now we plug into our formula. There equals 1/2. We already know 20 times 20. And I usually use the product over 2, but because I've been doing that so often, I decided to concentrate more on using the fraction button, so you guys will practice it using that on your test. I'm trying to get back to the home page where I can find our digital calculator. So remember, if we want to use 1/2, 1 ABC2 times 28 times 20 equals. So the area of this rhombus is 28. But we can't just write 28, right? Because it's area. So we've got to square our unit measure. So it's 28 square meters. 280 square meters, that is. I'm sorry, my pen's coming to life. So 280 square meters. Any questions? All right. Example 2, in rhombus ABCD, below AB equals 10. So go ahead and label that. 10 millimeters and AE equals 6. Be sure to include the correct unit in your answer. So we didn't get either diagonal in the given information, right? Hopefully you recognize that AC is a diagonal and BD is a diagonal. Can we determine the length of AC based on the given information? How long is AC going to be? 12, right? So if it's bisected, if this is 6 and this is 6, now we know that's going to be 12. Actually, let's put 2 times 6 there to make it a little clearer. And now, BD. We know this is congruent to this, but we don't know either length, right? I have a right angle here. You don't have a right angle on yours. I need to remind you that the diagonals form right angles. So while we do not know the length of either part of that diagonal, we do have enough information to find the length of BE, and then we could multiply it by 2, right? How can we find the length of BE if this is a right triangle? Anybody have an idea? Xavier?
The Pythagorean theorem.
Great. That's exactly what I would do. A squared plus B squared equals C squared. I'm going to call that A. And then once I know what A is, I can multiply it by 2. And I'll know how long diagonal 2 is. So I'm only calling it A because it's one of the legs, and I'm going to solve for it. So I'm going to leave that one as the variable. Remember, in a right triangle, the legs are the A and B, so the B is 6, so 6 squared. And the hypotenuse is always across from the right angle, so that's 10 squared. We're going to subtract 6 squared from both sides. And we can use our calculator and do it just like that. Remember, the fewer keystrokes in the calculator, sometimes the better chance we have of getting things right. 10x squared minus 6x squared equals 64. So a squared is 64. We don't want to know what a squared is, though. We want to know what a is. How do we find what a is? Square root. Very good. So now we know if we go back here, use our square root button. Now we know that a is 8. So if a is 8, BD is also 8. So now we know BD is 2 times 8, or 16. So far, so good? All right. So we're going to plug into our formula now. The area equals 1/2 times 12 times 16. These are millimeters, so we know our answer is going to be millimeters squared. So we can use our calculator, use the ABC button again. Figure what it was, 12 and 16? Did you guys get 96? Anybody get something different? So the area of this rhombus is 96 square meters. And the rhombus below, let's get out of that. And rhombus WXYZ, WX is 26, and VY is 24. Once again, we have neither diagonal. Hopefully you're recognizing at this point that YW is a diagonal and XZ is a diagonal. Can anybody tell me how to find the length of diagonal WY? Can you tell me how to find the length of WY? Morgan? How long is WY? Segment WY. Yep. How'd you get it? These are congruent. 2 times 24 is 48, or you can add them together. So XZ is this diagonal here, that shorter diagonal. Now we've got to figure out how long XZ is, but the only way we're going to do that is to find out how long XZ is and then multiply it by 2. So that's what we're going to do. Once again, we're going to plug into the Pythagorean theorem. So a squared plus b squared equals c squared. We're going to call this A again. It's one of the legs. We're finding one of the lengths of the legs. The hypotenuse is never going to be part of the diagonal. So a squared plus the b, the other leg, is has a length of 24. So it's plus 24 squared equals 26 squared. So subtract 24 squared from 26 squared. 26x squared minus 24x squared is 100. So a squared equals 100. And then a equals 10. So if a is 10, xz is 10. Now we know zz is 10. So this diagonal is 2 times 10, or 20. So 1/2 times each diagonal. See what you get. Everybody make sure you're practicing putting it in. I am going to ask when you're working on your assignment to read it consider write on or write with. I did have people finishing it in class today, and then you work on your path. What did you get, Thomas?
Hold on. I got 480, but
What did you get, Harlan? 480. What did you get, Vivian? 480. That's exactly right. And what is our unit of measure? What's our unit of measure, Thomas?
meters squared.
Perfect. All right. Any questions? Y'all caught up with me? The area of the kite. So they're going to give you some figures where you're going to need the diagonal, or you're going to need the length of bases for the trapezoid or whatever, but they're not telling you how that long they are. So we could use a distance formula on these, but when they give them to you vertically or horizontally, we can also just count or subtract coordinates. So let's go to mark our diagonals that we're looking for the length of. Let's start with this one. We're going to call this one diagonal 1. Okay, how long is diagonal 1? We know it starts here and ends here. So we could count from 1 up to 7. 1, 2, 3, 4, 5, 6, right? The other way to do it is to take the absolute value of the coordinates. We're looking for distance, right? So the horizontal diagonal, we're going to look at the x-coordinates, right? So 1 minus 7 is negative 6. So remember, if we want the distance, it's the absolute value of that. So the absolute value of negative 6 is positive 6. The distance, the length is always going to be a positive. So if this is our diagonal sub 1, its length is 6. Does that make sense? That makes sense, Gabrielle? All right, so how long is that vertical diagonal? Well, now we're going to be looking at the y-coordinates. So it's up to here, down to here. If all the units are marked, we could just count them. We could also count from here to the x-axis, that's 3. Right, from here to here is 3. We can count from here up, that's 5. So now we know that if you add them together, that's 8. The other option, I'm going to go to that in a minute. The other option, like I said, is to subtract the coordinates. It doesn't matter if I go from here to here, or the top one to the bottom one. As long as you take the absolute value, you get the same thing. So 3 minus negative 5, absolute value of positive 8 is 8. So number 8 is 8 units from 0. If it were a negative 8, it would still be 8 units from 0. So now we're going to plug into our formula. So now we know the area of this type. What'd you get, Devanshi? What'd you get, Tori? What'd you get, Charlie? What'd you get, Harlan? 24. Oh, 24. They did not give you what type of unit it was, so it's just labeled as a square unit. All right. Y'all caught up with me? Any questions? All right. So this is the one I messed up in second period today. I had these marked as diagonals, labeled as diagonals, which this is a trapezoid. You have to remember to plug into the trapezoid, not the rhombus or the kite area formula, but the area for a trapezoid, which is on our reference sheet. It's 1/2 times the height of the trapezoid times the sum of the two bases. We have to remember that the two bases are these parallel sides. And then the height is the distance between them, right? So from here to here. So we need the length of the bases and the length of the height. And we can do it exactly the same way we did for that, the kite in the last frame. We're going to call this one on the left base 1. How long is base 1? Can you tell me? What's the length of base 1 here? Say it again, Kellen. 13. How'd you get that? Perfect. So 8 minus negative 5. The absolute value of positive 13 is 13. You could also, well, from here to here is 8, right? From here to here is 5. So a couple of different ways you can find the length when they give it to you on the coordinate plane. You could always subtract them. What's the length of base 2? Sharia? How long is base 2? So base 2 is going to be this side. Eight? You say 8? How far is it from here to here? Sorry? Nope, not 16. How far is it from this point to the x-axis? So if we're looking at vertical lines that we need to plug in our formula, we're always looking at the y-coordinate. Right, the y-coordinate. So if we're subtracting, it's going to be y minus y here. Absolute value of y minus y. We could also count from here to here is 6. From here to here is 3. Does that make sense? If you start here and count up to x, you get 3. If you start here and count down to x, you get 6. So that side is 9 units long. We could also use the Pythagorean or absolute value of the difference of the y-coordinate. So that's going to be 9. What is the height of this trapezoid? Can you tell me the height of this trapezoid? Miles, what's the height of this trapezoid? 4. How'd you get that? Negative 3 and 1. So negative 3 minus 1, that gives us the absolute value of negative 4. The absolute value of negative 4 is positive 4. If that doesn't make sense to you, from here to the x, or to the origin here, to the y-axis. So this is a 3, right? Negative 3. So 1, 2, 3. That's 3 units. This is 1 unit. So if I count back this way, that's 1 unit. So you can do it either way, but the height has a length of 4. And now we plug into that formula, which somehow I did not do. So make sure you're looking and picking out your formula. So you do as I say, not as I always do. Right, so the area is 1/2 times the height of 4 times the sum of 13 and 9. So we can do that on our calculator. Clear it out. 1 ABC 2 times 4 times left parentheses 13 plus 9 right parentheses and equals. You guys put 44? Alright, great. So far, so good? Y'all caught up with me? Anybody need another second? Alright. What's the area of the rhombus? So let's remind ourselves. Remember, this one is not on your formula sheet. So it's 1/2 times diagonal 1 times diagonal 2. We're counting or subtracting here again. So we're going to call this one diagonal 1. How long is this diagonal? This is negative 1 here. This is negative 7 here. If I count down, that would be 6. We could also subtract. Can't write. Negative 1 minus negative 7, absolute value of that. That's going to be the absolute value of positive 6. So that is 6. So you can count from here to here, or you can subtract the coordinates. Just remember, it's got to be positive. It's got to be the absolute value, because that's good. And then let's find the length of this one. Can you tell me the length of the second diagonal? How long is that diagonal? Amaya? 12, very good. From here to here is 8. From here to here is 4. Or we should subtract our coordinates. If it's a horizontal diagonal, we're subtracting the x-coordinates. Negative 8 minus 4. To the absolute value, that's absolute value is negative 12 and is positive 12. Now we plug into our formula. What'd you get, Tori? What'd you get, Elizabeth? Anybody get something different? 36 is what I got. 36 square units. Alright, that's it. We're going to do our homework before we stand for this. You're done with your assignment? Did you get a 100? Yes, as long as you get a 100. When did you work on your assignment?